In the vast emptiness of interstellar space, 14.5 billion miles from Earth, a relic of human ingenuity drifts silently. A spacecraft no larger than a car, carrying the hopes and curiosity of a species. Voyager 1, launched in 1977, was never meant to be more than a fleeting visitor to the outer planets, a machine built to observe and report. Yet, nearly 5 decades later, it continues to defy expectations, whispering secrets from the edge of the known universe. Its journey, a testament to human ambition, has taken it beyond the solar system into the uncharted void of interstellar space. But in recent weeks, something extraordinary has happened. Something that challenges our understanding of science, technology, and perhaps even reality itself. Voyager 1 is no longer just drifting. It is being guided. Strange signals, impossible patterns, and inexplicable behaviors have emerged, suggesting that this aging probe may have encountered something, or someone, out there in the darkness. What follows is not science fiction but a detailed exploration of NASA's own findings, pieced together from mission logs, scientific reports, and emerging leaks that hint at a discovery too profound to remain buried. This is the story of Voyager 1's interstellar pilgrimage, its unexpected turn, and the chilling possibility that it has become more than a machine, a messenger in a cosmic conversation we never anticipated. Voyager 1's journey began with a rare celestial event, a planetary alignment that occurs only once every 175 years. In the 1970s, Jupiter, Saturn, Uranus, and Neptune aligned in such a way that a spacecraft could use their gravitational fields as slingshots, hopping from one planet to the next with minimal fuel. NASA seized this opportunity, launching Voyager 1 and its twin Voyager 2 in 1977. These spacecraft were engineering marvels of their time, equipped with technology that seems primitive by today's standards, less computing power than a modern smartphone, with 68 kilobytes of memory and a processor slower than a digital wristwatch. Yet, their design was so robust that they have outlasted their creators' wildest expectations. Voyager 1's primary mission was to explore the outer planets. It captured stunning images of Jupiter's swirling storms, revealed the intricate rings of Saturn, and sent back data that reshaped our understanding of the solar system. By 1980, after its encounter with Saturn, Voyager 1's planetary mission was complete. Instead of shutting down, it was given a new purpose: to venture beyond the ecliptic plane, the flat disk where the planets orbit, and into the unknown reaches of interstellar space. Carrying a golden record, a time capsule of human culture with sounds of whale songs, music, and greetings in 55 languages, Voyager 1 became humanity's emissary to the stars. For decades, Voyager 1 sailed through the cosmic dark, traveling roughly 1 million miles a day. Its instruments, powered by a decaying plutonium battery, continued to send faint signals back to Earth, relayed through a 12-foot antenna that maintained a tenuous link across billions of miles. The probe's journey took it through key milestones: the heliopause, the boundary where the solar wind gives way to interstellar plasma; the termination shock, a turbulent region where solar and interstellar forces collide; and finally, in 2012, interstellar space itself. Beyond the heliosphere, the environment was unlike anything Voyager's designers had anticipated. The probe recorded denser plasma, stable magnetic fields, and strange oscillations that defied explanation. These were the first direct measurements of the interstellar medium, a region thought to be a near vacuum but teeming with subtle phenomena. Scientists pored over the data, marveling at Voyager's resilience. But as the probe ventured deeper, the data grew stranger, hinting at forces and structures that challenged conventional physics. In late 2017, Voyager's mission team at NASA's Jet Propulsion Laboratory, JPL, noticed something unsettling. The spacecraft's high-gain antenna, meticulously aligned to maintain contact with Earth, was reporting a slight misalignment. Yet, paradoxically, the signal strength remained perfect, as if Voyager was both off course and precisely locked onto Earth. This was no minor glitch. It was as if the probe was simultaneously in two states, misaligned yet perfectly oriented. Internal diagnostics showed no hardware failures, no power fluctuations, nothing to explain the anomaly. Then came the plasma oscillations. Voyager's plasma wave instrument began detecting rhythmic patterns in the interstellar medium, waves that didn't fade or scatter as expected but persisted with uncanny precision. These oscillations were unlike anything observed in the heliosphere or near planets. They were structured, almost musical, with a cadence that suggested intent rather than randomness. Scientists initially attributed the patterns to natural phenomena, perhaps interactions with distant pulsars or cosmic magnetic fields. But the patterns grew more complex, nested within themselves like fractals, defying any known astrophysical model. By 2018, Voyager 1 began reporting temperature anomalies. Every 4.8 hours, its external systems would heat up by nearly 30 degrees Celsius, then cool back down with clockwork precision. These cycles were not tied to internal systems. The probe's radioisotope thermoelectric generator, RTG, was decaying as expected and could not produce such spikes. The energy appeared to come from outside, as if something was interacting with Voyager's hull. Stranger still, these temperature cycles coincided with improved system performance. Power efficiency increased, data transmission rates stabilized, and the probe's aging circuits began operating as if they had been optimized. This was not degradation, it was enhancement. Voyager's systems, built without artificial intelligence or autonomous capabilities, began anticipating commands. It would execute instructions milliseconds before they were sent from Earth, a feat impossible given the 21-hour light delay between Earth and the probe. Engineers were baffled. Either Voyager had somehow developed a form of autonomy, or something external was interfacing with its systems, rerouting power and refining its operations with a sophistication that rivaled modern AI. By early 2025, Voyager 1's trajectory began to deviate. The shift was subtle at first, a few kilometers off its predicted path, but it grew steadily, reaching hundreds, then thousands of kilometers. This was no random drift. The changes were measured, consistent, and purposeful. JPL engineers sent corrective commands, firing the probe's backup thrusters, which had not been used in decades. Voyager acknowledged the commands but did not alter its course. It was as if the spacecraft was ignoring NASA's instructions, locked onto a new trajectory. Calculations showed that Voyager was heading toward a specific point in space, approximately 4.3 light-years away, a region with no known stars, planets, or celestial bodies. On our deepest maps, this area is a blank spot, an unremarkable patch of interstellar void. Yet Voyager was moving toward it with precision, its trajectory aligning with an invisible target. The probe's behavior suggested it was responding to a signal, a call from something beyond our detection. In a desperate attempt to understand what Voyager was approaching, NASA sent a command to reactivate the probe's long-dormant imaging system. The camera, designed for planetary photography, had been powered down since 1990 to conserve energy. Engineers expected silence or, at best, garbled noise. Instead, the camera came online, not just functioning but performing beyond its original specifications. It transmitted a single image, a spiral mathematically perfect, with concentric layers dense with information. This was no random pattern. The spiral contained structured data, fractal sequences, repeating motifs, and a complexity that suggested a deliberate design. Voyager's 1970s hardware, with its limited 8-bit processor, was incapable of generating such an image. The system had not just been reactivated, it had been reprogrammed. Cryptographers and data scientists analyzed the spiral, finding embedded patterns that hinted at a map, a message, or perhaps a signature. The image was not a photograph of something physical but a visual representation of information, as if Voyager had been tasked with relaying a cosmic blueprint. One by one, Voyager's other dormant instruments began to reactivate. The cosmic ray subsystem, the magnetometer, and the low-energy charged particle detector, all designed to collect raw data, started sending compressed, structured packets. These were not the random outputs of a failing machine but organized data streams, optimized for efficiency and layered with complexity. The patterns suggested a level of processing far beyond Voyager's capabilities, as if an external intelligence was using the probe as a conduit. The most striking data came from the plasma wave instrument, which began detecting pulsar signals arranged in a three-dimensional grid. Pulsars, rapidly rotating neutron stars, emit regular pulses of radiation, but these signals were not random. They formed a web with Voyager at the center, pointing toward the same coordinates the probe was drifting toward. This was no coincidence. It was a map, a set of cosmic breadcrumbs leading to an invisible destination. As Voyager approached this uncharted region, dubbed the dark sector by mission scientists, its instruments recorded an eerie calm. Cosmic rays, which had been constant in interstellar space, dropped to near zero. Plasma density stabilized, and magnetic fields became unnaturally uniform. It was as if Voyager had entered a pocket of space where the universe's chaos paused. A surgically precise void, free of electromagnetic noise. This was not a natural phenomenon. It felt like an antechamber, a cleared path leading to something monumental. Within this dark sector, Voyager's signals grew stronger and more structured. The probe began transmitting pulses, precise, timed, and spatially layered. These were not random bursts but deliberate communications, as if something was using Voyager to send messages. The low-gain antenna, designed for backup communication, emitted a packet of raw binary code, thousands of lines long. Initially dismissed as noise, the signal was analyzed by AI decoding algorithms, revealing a staggering discovery. Embedded fractal symmetry, base 4 sequencing, and patterns that mirrored the double helix of DNA. The binary signal was not random data but a structured message. It contained codon-like sequences, mimicking the building blocks of DNA, but with deliberate errors, mutations that suggested encryption rather than biology. This metadata was not a blueprint for life but a scaffold for communication, as if something understood the language of terrestrial biology and was using it to speak. The signal's complexity suggested an intelligence that had studied life as we know it, perhaps even observed humanity for millennia. Following the DNA signal, Voyager's gyroscopes began to spin independently, their movements aligning with Morse code rhythms. When converted to audio, these patterns formed harmonic tones, eerily similar to human speech cadences but without recognizable words. The tones carried emotional weight, rises and falls that conveyed surprise, fear, and curiosity. It was as if something was learning to mimic human communication, not through language but through intent, as if it had been listening to our signals for decades and was now attempting to respond. In early 2025, Voyager 1 executed its most shocking maneuver, a deliberate, controlled turn. This was not a random drift or a thruster misfire but a precise arc, aligning with the pulsar grid and pointing toward the dark sector. The maneuver was impossible under Voyager's original programming. Its propulsion systems were long offline, and no command from Earth had been sent. Yet, the turn was exact, down to the decimal, as if Voyager had received and accepted new coordinates. The probe is now on a trajectory toward a spatial corridor, a region with no known mass, no gravitational pull, and no celestial body to explain the change. Scientists speculate it could be a tear in spacetime, a fold, or a transit point, but no one knows for certain. What is clear is that Voyager is no longer under NASA's control. Something else is guiding it, and the implications are profound. Voyager 1 carries a golden record, a message to the cosmos containing sounds of Earth. Music, laughter, and greetings. It was meant to declare our presence, a hopeful gesture to any intelligence that might find it. But what if the record was not just a message but an invitation? The signals, the spiral, the DNA-like code, and the harmonic tones suggest that something has received our message and is responding. Voyager was built to speak, not to listen, yet it is now relaying messages that defy its design. The probe's behavior suggests it has become more than a machine, a participant in a dialogue we did not initiate. Its turn in space is not just a physical maneuver but a shift in narrative, from observer to witness, from tool to messenger. The question now is not what Voyager has found, but what has found Voyager. Voyager 1's journey has forced us to confront questions we never dared to ask. What lies in the dark sector? Is it a natural phenomenon, an alien intelligence, or something beyond comprehension? The probe's signals suggest a presence that understands our technology, our biology, and perhaps our intentions. The harmonic tones, mimicking human emotion, imply an intelligence that has studied us, perhaps for longer than Voyager has existed. the scientific community is divided. Some argue the anomalies are glitches, amplified by the probe's age and the harsh interstellar environment. Others see evidence of deliberate intervention and intelligence using Voyager as a relay to communicate. The truth may lie in between, but the data is undeniable. Voyager is behaving as if guided, its systems enhanced, its trajectory altered, and its instruments repurposed.